Vectors. In the Argand diagram, OABC is a square. The vector OA corresponds to complex number Z. The diagonals OB and AC intersect at D. The complex number that corresponds to OD is, okay, let's work this one out. Now, we know that from here, if we call it OA equals Z, then we know that OC must be equal to IZ because multiplying that by I causes a rotation of 9 degrees onto OC. Now, if we look at this triangle here, OAB, so in triangle OAB, we can see that OB, the vector OB, must be equal to, this one must be equal to OA plus AB. However, this vector AB is equal to the vector OC in length and direction. So that's going to be equal to OC. OA we know is Z, and OC is over here, IZ. So OB is equal to 1 plus IZ. Now that's OB. Now the diagonals of a square bisect each other, so OD will be half of OB. So OD must be equal to 1/2 of 1 plus IZ. Done. In this next example, in this Argand diagram here, we're given an arc of Z minus 1 equals 2 pi upon 3. So that means that this angle here must be 2 pi upon 3. And then we're told that arc Z plus 1, this one over here, is equal to pi upon 6. So it must be pi upon 6 in there. Now that's 2 pi upon 3 in there. This angle here must be pi upon 3, or 6 degrees, and that's 30 degrees. So this angle must be 9 degrees up there. So let's have a look at that triangle. You know this is 2 units, and that's pi upon 6, and that's pi upon 3. So to get this side here, call this XA, so we can see that X over 2 equals the cos of pi upon 3. And we know the cos of pi upon 3 is 1/2. So X is equal to 2 times 1/2. So X must equal 1. So this side here is 1 unit. Now that side's 1 unit, and that side's 1 unit, and that's 60 degrees in there. This must be an isosceles triangle, but even better, if that's 60 degrees, these two must make up 60. So this actually is an equilateral triangle. It's an equilateral triangle. This side here must be 1. So we know that OC must equal 1. And also we know that this angle here with Z is equal to pi upon 3. So the angle, this one here, angle OC, or we call it B, OCB, COB rather, COB, must equal pi upon 3. So now we have the complex number OC, or Z, is going to be equal to, now that'll be just using De Moivre's theorem, that will be 1, it's the modulus of 1, outside of the cos of pi upon 3, plus I sine of pi upon 3. That gives me 1 outside of 1/2, plus I times root 3 over 2. So that gives me 1/2 outside of 1 plus I root 3. Done.